Welcome to my review of Scratch. Scratch can be accessed at scratch.mit.edu. It is free and it can be accessed by clicking the Start Creating button and loading the online editor, or by clicking the download page and downloading it for Windows, Mac, Chrome, or Android. At its heart, Scratch is a visual programming language targeted at ages 8 through 16. It allows students to learn the fundamental concepts of coding with if-else statements, variables for storing data, and loops. I've personally used this with grade 9 students, ages 14 and 15, with great success. Students can create interactive displays, mini games, and stories by constructing in the code panel and playing it on the stage. Let's do a quick example together. The code will begin running when we click the green flag button here. So let's add an event that takes place when the green flag gets clicked. We are going to react to when the character moves to the right edge of the screen and hits the goal of the screen. So we want this code to keep running as long as the program is being played. So we're going to use the forever loop. And what we want to do is we want to check what the X position of the character is. So we can use an if block, and now out of the motion tab in Scratch we can get the X coordinate of our character. And what we want to do with this is figure out if it is reaching the edge of the screen. And off of the operators tab, let's grab the greater than operation and let's set it up so that we can check if the X position is greater than 180. And this can get dropped into the if statement. And let's just have our character display a little message here. So off of the looks category, we can use the think operation, thinking, hey, made it. And if we see this in action here, let's turn on the game, and as we get towards the goal, we made it. In Scratch, sprites are located on a Cartesian XY plane. The coordinates are on the domain for X going from negative 240 on the left to positive 240 on the right, and on a range of negative 160 at the bottom to positive 160 on the top. That means the resolution of the play field is 480 by 320. This makes it suitable for small screens, which is great for use on Chromebooks, tablets, small laptops, etc. When working with variables, students will also be engaged with numerical operations on rational numbers. Manipulating the values of variables will require reasoning and logic. In our example here, we used an operation to determine the X coordinate of the current sprite. Developing a larger product, which could be a story with multiple characters or a playable minigame, will engage students in broader logical thinking skills, as well as integrate communication into a mathematical context. The last time I had my grade 9s make minigames, students were also responsible for writing a README document that explained how to play their game. This was very valuable for the gallery walk activity that we did, where their classmates played their games and provided some feedback.